Trial and improvement is the process of taking an educated guess, so just taking a good guess roughly in the region where you think it's going to be, seeing what result you get, and then improving on your previous guess with a new one. So, for example, the solution to the equation x cubed minus 6x equals 72 lies between 4 and 5. Use trial and improvement to find a solution correct to one decimal place. So the first step is make some sort of educated guess. Here we don't know whether it's closer to 4, whether it's closer to 5, so I'm going to pick exactly in the middle. I'm going to choose x is 4.5. It's useful to create a little table, especially if you end up taking multiple guesses before you get to the answer. So let's say x, and let's say outcome, and let's say conclusion. Substituting x is 4.5 in, so x is 4.5 into this equation, x cubed minus 6x, where x is 4.5, gives you 64.125, which is clearly not as big as 72. So the conclusion I'll make from this is too small. So let's make a better guess. Let's guess 4.6. Substituting this in gets you 69.736. I'm just keeping it to 3 decimal places because obviously we don't need to be mega exact for this. You see again, that's smaller than 72. So our solution was too small. But we're getting a bit closer now. So let's take another guess. Let's guess 4.7. Substituting this in gets us 75.623. So that's too big now. We're looking for 72. But we now have at least one that is too small and one that's too big, so we know that it's somewhere in between 4.6 and 4.7. So let's see which one it's closer to, because we only want to find it to one decimal place. It's going to be one of these two. We need to figure out which one it's closer to. So let's take halfway in between those. Let's take 4.65. Substituting this in, we get 72.645 to 3 decimal places. So you can see that's too big. Okay? So that would suggest that our substituted value of x was too large, so it needs to be a little bit smaller. And remember, we only want it to 1 decimal place. So smaller than this, it's going to round down to 4.6. So our solution in this case is x is 4.6, because that gets us roughly 72 to 1 decimal place. You'll see it's not actually that close, but it's closer than 4.7 was.